Good afternoon, class. This is Math with Mr. Samuels. Just like usual, make sure you have your notes so that you can follow along with the video. Okay. And then also, you're going to do all the practice problems at the end of the video. So let's go ahead and get busy. So today we're talking about slope. Okay. So that's our topic, slope. Okay. And so, first and foremost, another way that we describe slope, another way that we talk about slope is called a rate of change. Okay. So what is a rate of change? A rate of change is a ratio that shows how one variable changes with respect to another variable. Okay? And the variables that we are referring to are y and x. Okay. So let's continue with our notes. On a linear graph, this is called the slope, okay, of the line. So when we're talking about slope, slope is written as a ratio. Okay, remember, when we call something a ratio, remember, ratio is just a fraction. And so that ratio is the vertical change, which is the rise, to the horizontal change, which is the run, between any 2 points on a line. Okay. This remains constant, people. It does not change. Okay. It remains constant as the line increases or as the line falls. Okay. As the slope increases or as the line goes down, the slope always stays constant. Okay. Slope is written as a fraction. Always, when we deal with fractions, it's always going to be in simplest form. Okay. And the variable that we represent slope with is m. Okay, anytime you see m throughout this unit, just know that we are referring to slope. Okay, anytime you see m, just know that we are referring to slope. Okay, so let's do a couple of examples. So we have many different types of slope. Okay, one of the first slopes that we have is when a line looks like so. Okay. And this type of slope is known as a positive slope. Okay. And we also have the opposite of positive, which is negative. We also have a negative slope when a line looks like that. Okay. And this is a negative slope. Okay. Keeping it moving. We also have a zero slope. Well, what would a zero slope look like? You probably guessed it. A zero slope would be a flat line. Okay. When I always think of slope, I always think of a hill. Okay. Or some type of incline. Okay. If there is no incline, then obviously it's going to be a zero slope. And the last example we have is a little thing we like to call undefined. Okay. And that's when we have a vertical line. Okay. If we have a vertical line, that slope is going to be undefined. I will show you an example of an undefined slope as well in this video so that you can understand exactly what that looks like. Okay. So with that being said, let's go ahead and do a couple of examples. Okay. So our first example is going to be number 1. Okay. So remember, slope is a ratio, and that ratio is rise over run. Okay. Rise over run. Okay, it's always rise over run. So with that being said, let's do an example. Okay, hold on one second. Let me fix this really quickly. That looks a little better. There we go. So now, let's do the first one. So we need to see what the slope of this line is going to be. So first and foremost, we start at both points, or where it crosses at a corner, okay? And we count 1, 2, 3, 4. So our rise is going to be 4. And our run is going to be 1, 2, 3, 4, 5. So the slope of this line is going to be 4/5. Okay, pretty straightforward, right? Let's do another example. Okay, let's do number 3. So let's see what our rise is going to be. Okay, we have 1, 2. Since we're going up, it's going to be positive. So that's a positive 2. And now we have 1, 2, 3, 4, 5, 6. Now, before we finish this problem, I want to ask you, anytime we move left on the number line, the numbers are always what? Exactly. You guessed it. They're always negative. So anytime we're moving to the left, okay, when we're talking about our run, then that second number is going to be negative. So as a result, we have -6 for our second one. But as we look at this, we notice that this can be reduced, okay? And when we reduce this, it will be reduced down to 1/-3, okay? Negative. All right, so let's do another example. Okay, how about number 5, okay? As you can look, number 5 is a vertical line. So we don't have to do anything. We don't have to really say anything because there is nothing to be said. We already know that anytime we see a vertical line, that slope is always going to be undefined. Okay? Keeping it moving. Let's do one last example and then we're going to be done. Let's do number 8, okay? So if we're looking at number 8, as you can see, number 8, we start here and we count. What is our rise? We go up 1, 2, 3, 4. So our rise is going to be 4. And let's see, our run is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4/10, okay? Now, as you all know, both of these numbers are even, so we can reduce both of these, okay? And when we reduce it, it's going to be reduced down to 2/5, okay? So you guys are going to go ahead and do all of the problems that we did not do. So it looks like number 2, number 4, 5, number 6, 7, 9, 10, 11, 12, 13, 14. I'm going to post the answers in class tomorrow. Okay, make sure you complete those practice problems. Once again, this has been Math with Mr. Samuels. Have a good day, good morning, good evening. Have a great afternoon.